Hi, I'm Uday, and this is Soloraa. Every AI agent that touches money today is holding a private key. Soloraa deletes that key. AI agents are about to control real money, but today most AI agents wallets are basically hotkeys wrapped in prompts. If the model is jailbroken, hallucinating, or prompt injected, the wallet is drained. So we built Soloraa, a cryptographic execution layer on Solana where agents never hold private keys. Now let me show you the architecture Soloraa follows. Solana moves the trust boundary onto Solana itself. An attested enclave validates and signs a canonical intent, and the Solana program independently re-verifies every constraint on-chain before funds move. The relay is untrusted, the app is untrusted, even the agent itself is untrusted. Only the chain is the verifier. Now let's connect the wallet. Let me disconnect it and show you how it is connected. Connect wallet. Let's choose Phantom. It is connected. Now there are many agents available on our site. You can run anyone. I'm choosing the market making. So this is a market making agent running on Sol and USDC. Before it can move a single lamport, a user delegates a bounded amount into a wallet PDA. Now let me refresh it and show it one more time. Okay. Now before it can move a single lamport, the user delegates a bounded amount into a wallet PDA. The policy lives on chain, the max state size, slippage limits, allowed program, allowed tokens, expiry windows, and replay protection. The agent itself never holds a private key. The enclave signs only if every policy checks passes. Now let's delegate it some capital. I'm delegating 250 USDC. Approve. Let's let me type my password. Now let's sign it. Now the agent is running. The page passing data is verified through wormhole guardians and Merkle proofs inside the enclave. The canonical Soloraa intent v2 message is constructed and the enclave signed it using a sealed 2519 ED25519 key inside the key. The transaction is assembled with a native ED25519 verification instruction and the Soloraa verify program. The relayer broadcasts the transaction, but the relayer itself is untrusted. Three live execution legs are broadcasting in sequence now. You can see first the quota refresh. Now let's sign the transaction. Second, a marker fill, also sign this transaction. And last, an inventory rebalance. Let's sign it. Each one is a separate Solana devnet transaction moving through the verified pipeline. You can see the status changes from broadcast to verification to confirmation in real time. All right, the transactions are confirmed. Let me open the last transaction here. You can see the 825519 verification instruction, the Solana verify program, and the CPI into Phoenix. Everything executed through the on-chain policy checks exactly as expected. Now for the important part. This is the exact same signed intent from the previous transaction. Same bytes, same signature, same attested enclave. I'm replaying it as it is. Now replay the attack. You can see rejected, not by our backend, by the Solana program itself. Intent nonce mismatch errors 6018. The nonce was already consumed. The signature is valid and the bytes are identical and the chain still says no. This is the core idea behind Soloraa. Compromises the model, compromise the relayer, even compromise the surrounding application stack. Funds still do not move unless the proof is valid. Now you can also see the portfolio of every agent that is running now, the on-chain activity. And this isn't just our agent. Okay. Solana ships the as an SDK so developer can plug in the same cryptographic execution layer into their own autonomous strategies. 169 bytes, every byte verified on chain. The program is a verifier, not a trust anchor. So that is Solana.